So let's reset and look at our variability in here. So based on our guiding principles, we've come up with this scenario: primary and secondary in DC1, secondary in DC2, and an arbiter in a third data center to function as a tiebreaker. And the variable that we have is the capacity. So how might you alter things here? How might you deploy differently? Well, you wouldn't deploy any differently logically. The question here would be, what is the relative sizing of these various hosts? In particular, the most common split you would have here is if DC1 here is considered, your prime site or your hot site or whatever you designate it, and DC2 is literally a backup cold site, then if that's the case, and you're going to keep all your traffic here as long as everything's actually functioning normally, then you may not need as high a capacity here. In fact, these are going to be sitting idle most of the time. You may even have one of them hidden just in case if it's a particularly not as powerful a node. You'd always want this one here, for example, to become primary even in a failover scenario. There's many different ways you can kind of split your resources over here in DC2. Maybe these are all on VMs and you can allocate resources in a much more dynamic fashion over here in terms of need. So that's your variable. Are you okay with running at reduced capacity? If you're not okay at running at reduced capacity, you have to have machines, hosts, configurations in DC2 that are just as capable as DC1. You essentially double your cost for every deployment. You can see why it's a trade-off between cost and capacity and what happens in a failover here. So it's your classic trade-off. How well do you want the site to function during a failover? How close to the normal production performance does that actually have to be? And that's where you do your variability. From a logical layout perspective, though, the rest of the logic doesn't really change. In order to meet the avoiding data loss and avoiding downtime, you do need to go for this type of configuration. Now, you might decide that having a separate backup of the data inside each data center is a little bit over the top. In that case, you can just get rid of these two here and we go back to a 3-node data set. You've still got a copy in the separate data center. Maybe as a compromise there, what you do is make this a full secondary. Now you've got 3 copies in 3 separate locations. So as you can see, and as I said at the very top of this, it's always more complex than you expect. When you start going into this, you might be thinking, oh, I'll need a primary, I might need a secondary or 2. It won't be that complicated. But as soon as you start looking at the actual principles you're trying to enforce here, things become involved, things become complicated. And my final recommendation for any of these is test it. Don't deploy it and expect it to just work. Deploy it and make it fail. Make it fail on a regular basis. I've personally been involved in a disaster recovery that went badly, and it was where we had multiple redundant power into a data center to avoid downtime. That was our big thing. Let's not have downtime. Let's have multiple backups. We had diesel generators. We had diesel on site. They would spin up. We had temporary batteries to take the load in the meantime. While the diesel generators spun up and got up to capacity, the diesel generators were able to run all of our critical systems at full power the entire time. And what didn't happen was nobody tested to see if they actually still started. They weren't being tested frequently enough, and when it came around to an actual outage, the diesel generators failed to start. There was something wrong with the alternator or whatever the equivalent is in a big diesel generator, and they just wouldn't start, and they hadn't been tested often enough. So the best planning in the world, if you don't test it and make sure that it's still working at a reasonable rate, the best planning in the world can come to zero.